let's go Orange. Big weekend. Let's hope that they can make it through the first weekend. It's always more fun that way. Well, today we get into some fun with difference of perfect squares. So we're going to be doing factory again, which is the opposite of a process that we've already learned. And so hopefully by the end of this, you'll be able to factor an expression into an equivalent expression. We're not going to be finding the GCF. I apologize. This is incorrect. We're going to be trying to find or define what a perfect square is, okay? And I did put this in the Learning Targets page in the module, so you can go to that if you'd like to see it. What we're going to be doing here is taking conjugate pairs and rewriting them as the difference of two perfect squares. But first, we revisit the multiplying topic. Now, we touched on this with lesson number 28. So that would have been last Friday, where this was the easy way to do this. We could obviously take this first piece and break it up into two and multiply it by this, but something was going to happen. So let me go through the long process of x times x plus or x minus 6, and then 6, which is positive, times x minus 6 again. So we broke up the first one and multiplied it by the second one. This was going to create x times x. Remember, this is x squared because it's 1 plus 1, or basically two x's coming together, and then negative 6x. And then over here we had a positive 6x, and then a negative times a positive was going to be a negative 6 times 6. Remember, you are multiplying. Caught some people adding and subtracting there. No, that is multiplying for negative 36. So when I go to combine like terms, which are right here in the middle, a negative 6 with a positive 6, cancel out. And we were left with this binomial, in which the first term was a perfect square, x squared, and the second term was a perfect square. Now, what do I mean by that? I mean that they were created by multiplying the same thing together. X times x made x squared, and 6 times 6 made 36. So in actuality, there was a shortcut. And the shortcut was just to multiply the x and the x and the 6 with the 6 because they were going to cancel out. So I will continue to use the shortcut method rather than use the longer method, okay? Because here's what's going to happen. We know that a times a is going to be a squared, and b times b is going to make b squared, and the middle terms are going to cancel out. So essentially, we have 4 times 4, which is 4 squared, and x times x. Now, a negative times a positive is a negative, but it is going to be x squared. When we have the number, we can square that. That's 16. When it's the variable, it is obviously still x to the second power. Now, I don't have to write that first step. It helps maybe some of you see it, but let's skip that step completely and just go right to what we need to, which is the multiplication of the first terms. 5 times 5, 25, x times x, x to the second power. And then we go again with 2 times negative 2, and 2 times 2 is 4. And that's it. That's all. You don't have to do anything else. So my one box that has x squared in the middle, we know that that is created by multiplying 2 of the sides. Now all of the sides have a length of x, but we only multiply 2, so x times x. And 81 has an area of, that square has an area of 81, and the side lengths are going to be 9 and 9. Now, all of them are 9, but only 2 numbers are multiplied together to get the area, because it's side squared. So, where am I going with this? Well, this came from 2 binomials, okay? So you write down 2 binomials, and you put in x and x as the first term. All right, because that came from x squared. And then 81 came from 9 and 9. So 9 here with 9 here. And the signs for these are always different. One positive, one negative. That's why we call this the difference of 2 perfect squares. Okay? It's as easy as that, folks. Now we go ahead with no visual, all right? I'm not going to draw the boxes, but I do want to think about what this is going to look like. 2 binomials, where I break up the first piece. 9 is a perfect square. How do we get it? By multiplying 3 times 3. It's got to be the same number. That's why it's a perfect square. All sides are the same. X squared comes from x times x. There's two x's, so split them up. And then minus 4, well, what number is the same times itself that gives you 4? How about 2 and 2? So there they are. They look almost identical, but they're different by their signs. One positive and one negative. I do one more and then I take a quick pause. 25 minus y squared. Again, we are factoring this into two binomials, going back to what we started with, right? Remember, we started with two binomials and I multiplied to get to these new ones, okay? This equivalent expression. 25, is it a perfect square? Yes. What number times itself gets you to 25? How about 5 and 5? Next up, y to the second power. Well, there's two y's there, so split it up in y and y. Then have one be positive and one be negative, and that's it. Also, we've got d, which is 4x squared minus 81y squared. What can we do here? Well, we can't subtract them. They're not like terms, but we can factor them. So we're going to factor it into two binomials. And we just break it up into the same two binomials, except one's positive and one's negative. One's adding, one's subtracting, I should say. So 4x squared. What is 4 as a perfect square? How about 2 and 2? X squared, x with x. And then 81y squared. Well, 81 is a combination of 9 times 9. Y squared would be y there, y there. And that's it. We broke this up to make that. We broke this up to make that. One positive, one negative. Once you get the hang of this, I mean, you can almost start setting up your binomials so that you have one positive and one minus. Or excuse me, one negative, one positive, or one adding, one subtracting. 121 might be a sneaky one for you. So as always, you could take the square root, which we'll talk more about in the next unit. But what one number gets you to 121? It's actually 11. So 11 times 11, x squared would be x and x. 1 can be tricky, but don't think too long about it. What number times itself gives you 1, times itself that is? It's 1, right? 1 times 1? So positive 1, negative 1, because 1 times 1 is still 1. Finally, we finish up with the last one, and it does have another 1 in that, so if you didn't see it last time, hopefully we'll get that this time. 1. Well, again, 1 times 1 is still 1. We're multiplying. And then 4x squared. Break that up into 2x, 2x. And remember, 1 is positive, 1 is negative. And that's it. All she wrote for today. Just like I said, a quick, easy, nice Friday lesson. So there is your practice assignment. Please make sure you complete this.